Hi everyone, my name is Awais Imam and I'm faculty member of Virtual University of Pakistan and also a PhD scholar in Comsat Institute of Information Technology. And today I'm going to demonstrate linear regression and its diagnostics with SPSS. Let's start it with the assumptions of linear regression. Let's go on with the assumptions. Since we are dealing with linear regression, so we assume that there's a linear relationship between predictors and outcomes, and the second assumption is the error term has a normal distribution. The third assumption is the error term has mean equal to 0, and the fourth assumption is the errors have a same but unknown variance. This is also known as homoscedasticity assumption check. We'll discover it later on in SPSS. Fifth, error terms are independent of each other, that is, their pairwise covariance are 0. When this assumption does not hold, we have an autocorrelation problem. And we'll test it later on in SPSS. Now these are the standards, so you can see later on. 6. The independent variables are non-random and fixed. This assumption is satisfied only when experimental can set the values of independent variables at predetermined level. Normally it never happens in social sciences, but when we perform a true experimental design, and this case should be followed. 7th is the assumption of multi-kernelity. There should not be any multi-kernelity between independent variables. 8th, there should not be significant outlier, high leverage point or influence point. We'll see it later on. So we see it because there should not be any significant outlier which is affecting our model. If there is such, then our model is not depicting the true picture. 9, DV should be continuous. IV can be interval, continuous or dichotomous, but only with two categories, which means that if we have an IV which has more than two categories, that is 3, 4, 5, then we have to recode into a category of level 2. We are going to test this model in which standardized reading score is our dependent variable, and socioeconomic status, family size, self-concept and urban city is our independent variables. Now let's see the composition of these variables in SPSS. Now this is our DV, standardized reading score. We have social economic status. Where is it? This is our IV. Family size. This is our family size. Self-concept. So this is our self-concept, and urbanicity, and this is our urbanicity variable. And let's see their compositions. And now these two are categorical variable. Now this is sex, it is male and female. Now let's see the urban city. Now it has three categories: urban, suburban, rural. Now according to the assumption 9, we have to transform this variable into a categorical variable which has only two categories. So this variable will be recorded into two separate variables. Now let's see how we're going to do it. Now go to transform and record into different variables. In this case we have urban city. I'm going to transform it into two separate categorical variables which has only two categories, and by making one category a reference category. Now let's go back and see the composition of the urban city variable. Urban is 1, suburban is 2, rural is 3. So I'm going to make the reference category that is suburban 2 is equal to 0. Now let's go back to transform, record into different variables, select urban city, move it to here. Now I'm going to provide a new variable name which is urban, change. Now we are going to give values. Now in original urban city variable, urban has value 1, suburban has value 2, and rural has value 3. And now we have created a variable which is named urban, so I'm going to give values accordingly. Now watch this pattern. In previous, urban has 1, so its new value is 1. press add. Now for suburban, its value in the original variable is 2. I'm going to give it 0 because in binary dichotomous variable only 1 and 0 can exist. Press add. And for ruler, the original value was 3. It has to be 0 again. Press add, continue, press OK, and you will see here that a new variable has created, which is this. It has 1 or 0 values. You can label it value 1 as urban and value 0 as otherwise. Okay, good. Now I'm going to transform urban city to rural category by applying the same procedure. Let's see how we're going to do it again. We're going to transform, we got into different variables, reset it, then urban city over here, label it as rural, change, set the values. In previous data we have ruler is equal to 3, so we're going to 1 is equal to 0, 2 is equal to 0, and 3 is equal to 1. Now this sets the stage for our two dichotomous variables. Now if you have categories more than 4, 5, 6, it means that n-1 variables, dichotomous variables, should be created out of that variable. For instance, if you have categorical variable of having categories 5, it means n-1, that is 5 minus 1. 4 separate dichotomous variables will be created by making a one category a reference category. Now this satisfies our assumption 9, which states that IV should be dichotomous with only 2 categories. Now rural can be recorded just like we did with urban. Let's see. It with values, value 1 to rural, 0 to otherwise. Press OK. Let's see it. Good. Now we are ready to run this regression, but before running the regression we need to show that our data should be normal, so you need to check the normality of the data. I'm not going to check it here, but I'm going to just run the regression. The first assumption is that data should be linear, which is that there should be linear relationship between predictors and outcomes. Let's see. We're going to check it. We go to graphs, legacy, scatter diagram. I'm going to use simple scatter, define standardized score to y-axis and socioeconomic x-axis. Okay, let's wait. Now it's almost linear relationship, so you can test the rest by yourself. This meets our assumption 1, which is there should be a linear relationship between IV and DVs. Now we're ready to run the regression. We go to analyze, then go to regression, linear. Now our dependent variable is standardized reading score, and our independent variables are social economic factors, self-concept, family size. Now we will not use urban city over here because we have transformed it to urban and rural, so we are going to add these into IVs. Now come to statistics, check R-squared, descriptive statistics, and Durbin-Watson tests. Now Durbin-Watson test will cover the assumption 5, check collinearity, it will cover the assumption 7, press continue, go to plots. Now this will check the assumption 4, in Y, select Z, RSED, and in X-axis, check ZPRD. This will check the assumption of homoscedasticity. Now also check histogram, normal probability plot, continue. Now go to save, check standardized and standardized DF betas, press continue. This will check the assumption 3, press OK. Now we have the results with us, but we need to check more assumptions. Let's see how we're gonna do it. Now recall, when we were running the regression, we have saved the options of standardized residuals and standardized DF betas. Those options have given us now more values, which is ZRE1, so on. So ZRE1 is residual column. These are our error terms. With the help of this column, we will check the assumption 3 and so on our standardized DF betas. These columns will help us to determine the assumption 8. Now I'm going to take the mean of ZRE1. If the mean comes equal to 0, it means that we have met the assumption 3, that the error term has a mean equal to 0. And after that, I'm going to take the frequencies of these TF betas, and if the frequencies come in between of 2 and -2, it means we have met the assumption 8, that is, there is no significant outlier. Now I'm going to check the assumption 3. I go to analyze, descriptives, and where is standardized residuals, options, mean is checked, continue. Now you can see that mean is almost equal to 0, which satisfies our assumption that the error term has a mean equal to 0. Now I'm going to check the assumption 8, which is there should not be any significant outlier, high leverage point or influence point. We're going to check it by using the standard DF betas. For this, we go to analyze, descriptive statistics, frequencies, and select all DF betas into variables. Let's come to statistics. Over here, minimum, maximum, continue. We can see that almost all of the DF betas are in -2 and 2 range, which is good. Now we will see the assumption 2, that the error term has normal distribution. Now this is the histogram of residuals. This histogram has been drawn because we have selected the option of histogram in plots. You can see that it's almost normal, so our assumption 2 has been met. Now we'll check the assumption of autocorrelation, which is our assumption 5. It can be seen by using Durbin-Watson's test. It is almost equal to 2, so we can say that our assumption 5 has been met. After that, we'll check the assumption of multicollinearity, which is our assumption 7. It can be found in coefficient table. We can see that our VF values are less than 3, so we can say that this assumption has also been met. Now we have met all the assumptions of the regression. Now let's see our model is significant or not. The model significance can be seen by the model summary table. It is significant, and let's see the coefficients. Our coefficients: socioeconomic status is significant, self-concept is significant, family size, and urban and rural are insignificant. Now there's a difference between unstandardized coefficients and standardized coefficients. Unstandardized coefficients are those coefficients which have the units with themselves, and standardized coefficients are unit-free. Now last but not the least, we have also need to explain R square, which is 21%. It states that 21% of the variation in DV is caused by the IVs. Now this is the way how to perform regression in SPSS. That's all. Thank you.